Operating from a distant location beyond Earth's atmosphere, the telescope enjoys a stable environment that enables extremely precise measurements. This position allows it to observe faint and distant objects without many of the limitations faced by ground-based observatories. One of the mission's primary goals is to investigate the large-scale structure of the universe. Scientists are examining how galaxies cluster together, how matter is distributed throughout space, and how cosmic structures developed over time. The resulting maps represent one of the most ambitious attempts ever made to chart the universe. A major focus of this research involves dark matter, one of the greatest mysteries in modern science. Although it cannot be seen directly, its gravitational influence affects the movement of galaxies and the path of light traveling through space. By studying subtle distortions in the light from distant galaxies, researchers can trace the locations of this invisible matter and reveal structures that would otherwise remain hidden. These observations suggest that the visible universe may only be a small part of a much larger cosmic framework. Beneath the galaxies we can see lies an enormous network shaped by unseen matter and powerful gravitational forces. The first large-scale maps produced by the mission revealed extraordinary levels of detail. Countless galaxies appeared spread across vast distances, with some relatively nearby and others so distant that their light has traveled for billions of years before reaching Earth. Researchers have found that galaxies are not randomly distributed throughout space. Instead, they form intricate patterns resembling a gigantic cosmic web. Massive strands of matter connect clusters of galaxies, while enormous empty regions separate them. These voids may appear empty, yet they continue to provide valuable clues about how gravity and other cosmic forces shape the universe. Another mystery under investigation is dark energy, the phenomenon believed to drive the accelerating expansion of space. By observing how galaxies are distributed across different eras of cosmic history, scientists hope to better understand the role dark energy plays in the evolution of the universe. Detailed observations of galaxy clusters have also uncovered numerous faint dwarf galaxies that were previously difficult to detect. These small and dim systems may provide important insights into how galaxies form and interact over time. Because many of the observed galaxies are incredibly distant, astronomers are effectively looking back in time. The light from some of these objects began its journey billions of years ago, offering a glimpse into the universe during its earliest stages. This allows researchers to compare ancient galaxies with more recent ones and study how cosmic structures changed throughout history. Early findings have raised intriguing questions. Some large-scale structures appear more developed than certain models predicted, suggesting that aspects of our understanding of cosmic evolution may require refinement. As additional observations become available, scientists will continue testing these possibilities. The volume of information being collected is staggering. Over the course of the mission, data from billions of galaxies will be recorded, creating one of the largest astronomical datasets ever assembled. Advanced computing systems and artificial intelligence will play an important role in helping researchers analyze this immense amount of information. With every new observation, the universe appears more complex, interconnected, and mysterious. The deeper humanity looks into the cosmos, the more profound the questions become about the nature of reality, the origins of structure in the universe, and our place within this vast cosmic. For decades, Pluto existed on the distant frontier of our solar system, appearing as a small icy world far beyond the familiar planets. Most people viewed it as little more than a frozen remnant left over from the solar system's formation. Compared with massive worlds like Jupiter or Saturn, Pluto seemed insignificant and unlikely to hold many scientific secrets. Everything changed in 2006 when astronomers officially reclassified Pluto as a dwarf planet. The decision ended its long-standing status as the ninth planet and sparked debate across the globe. Many people who had grown up learning about 9 planets found the change difficult to accept. Even years later, Pluto remains one of the most emotionally discussed objects in astronomy. For a long time, scientists assumed Pluto was a quiet and inactive world. Because it orbits so far from the Sun, researchers believed its surface had remained largely unchanged for billions of years. The expectation was that Pluto would be covered mainly by ancient impact scars left behind by collisions from the distant past. As telescope technology improved, astronomers began gathering better observations of this distant object. The more they learned, the more Pluto challenged previous assumptions. Signs started to emerge that this frozen world might be far more complex than anyone had imagined. The real breakthrough arrived in 2015 when NASA's New Horizons spacecraft completed its historic flyby of Pluto after traveling across billions of miles of space. The mission delivered the first close-up images of the dwarf planet and revealed a world unlike anything scientists expected. Instead of a frozen and lifeless landscape, New Horizons discovered towering mountains, enormous plains of ice, unusual surface patterns, and regions that appeared surprisingly young. The findings suggested that Pluto may still experience geological activity despite its extreme distance from the Sun. One of the mission's most fascinating discoveries involved Pluto's atmosphere. Earlier models predicted a thin and relatively inactive layer of gas. However, observations showed a far more dynamic environment. Pluto's atmosphere contains nitrogen along with smaller amounts of methane and carbon monoxide. Researchers also detected multiple layers of haze extending high above the surface, giving the planet a striking bluish glow when illuminated by sunlight. Scientists believe sunlight triggers chemical reactions within these atmospheric gases. Over time, these reactions may create complex organic materials that slowly settle onto the surface, changing Pluto's appearance and chemistry. The surface itself offered even more surprises. While many expected to find only ancient cratered terrain, some areas appeared remarkably smooth. One of the most famous regions is a vast heart-shaped basin composed largely of frozen nitrogen. Evidence suggests that the ice there slowly circulates and shifts over time, behaving in some ways like glaciers on Earth. These observations hinted that Pluto is not a completely dormant world. Researchers began investigating whether cryovolcanism could be responsible for some of the landscape features. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes release mixtures of water, ammonia, and other frozen substances. Such activity could reshape the surface over immense periods of time. If cryovolcanic processes are occurring, they would indicate that Pluto still retains heat beneath its icy exterior. This possibility surprised many scientists because small bodies in the outer solar system were once expected to have cooled long ago. The source of that internal warmth remains an active area of research. Some scientists point to the slow decay of radioactive elements within Pluto's interior, while others suggest that heat from its early formation may still linger underground. Another intriguing discovery involves the presence of carbon-rich organic compounds. While these materials do not indicate the existence of life, they are considered important ingredients in the chemistry associated with living systems. Their presence raises questions about what kinds of chemical processes may be taking place beneath Pluto's frozen surface. Attention also turned toward Pluto's largest moon, Charon. Previously thought to be relatively uneventful, Charon revealed enormous canyons, rugged terrain, and unusual reddish deposits near its poles. Evidence suggests that the moon may have experienced significant geological changes in its past, including the possible existence of subsurface liquid water. The connection between Pluto and Charon is unique as well. Their gravitational relationship is so balanced that they orbit a common point in space located between them, making the pair resemble a double-world system rather than a typical planet and moon arrangement. Today, Pluto is no longer viewed as a simple frozen object at the edge of the solar system. It has become a fascinating world that continues to challenge scientific expectations. Every discovery reminds us that even the most distant corners of our cosmic neighborhood can hold